Now, selection of the fibers for surgical gowns. Fibers are the smallest unit of a textile fabric, and their properties are dependent on their chemical and physical properties. Chemically, the absorbency of the fiber is important to the transmission mechanism. Highly absorbent fibers remove the liquid, therefore halting the movement of the bacteria and trapping it within the fabric structure. When fibers of low absorbency are present, the liquid will weak along the fiber surface, enhancing capillary movement of the bacteria containing liquid. Natural fibers such as cotton and wool have higher absorbency capabilities than synthetic fibers, including polyolefin, polyester, and nylon rayon. Regenerated cellulosic fiber also has higher absorbency than this synthetic fiber. These physical properties or the surface morphology of the fiber also influence the barrier effectiveness. Fibers with irregular cross-section or irregular surface have the ability to trap particles as they travel, inhibiting particle transmission. Cotton fibers have convolutions ideal for trapping the small particles. Rayon is characterized by striations which provide some irregularity to the fiber surface. These striations are usually not pronounced and therefore are not as effective in trapping or inhibiting the movement of the bacteria as the convolutions found in cotton fibers on inhibiting the particle movements. The synthetic fibers are inherently smooth with circular cross-sections that allow particles to easily slide by the fiber. However, synthetic fibers with irregular cross-sections can be produced using appropriate dyes during extrusion or can be texturized to impart irregularity to their inherently smooth surface. Fiber length also influences the barrier properties of the fabric. Shorter fibers are more effective in preventing the transmission of small particles than longer fibers. Microfibers are now used in some gowns and drape fabrics. Microfiber is a fiber that has less than 1 nanometer per filament. Microfiber is the thinnest, finest of all man-made fibers and fabrics. Made from microfibers can meet the high specifications of barrier properties, fabrics. The most common fiber type used for surgical gowns and drapes are polypropylene and polyethylene fiber. Now, the selection of yarns for surgical gown apparel. The second component of a fabric is yarn, which is produced from fibers. Yarn produced from filament fibers usually contain less twist than yarn produced from staple fibers. The lower the twist, the bulkier the yarn with increased voids between the fibers. These interstitial spaces allow for the trapping of particles that move through the fabric. In the case of staple yarn, however, twist also results in protruding fibers and at the surface of the yarn. These small projections are ideal for trapping small particles. Additionally, they create an irregular surfaces which disrupts the formation of capillary forces as well, inhibiting the liquid movement. Now we will consider the fabric weave pattern. There are three basic methods of fabric construction, which are woven, knit, and non-woven. Reusable gowns are reprocessed, that is laundered and sterilized after reuse. Common fabrics typically used in reusable gowns have a woven or are tri-laminate construction. Plain weave. The first one, the plain weave is a fabric. Plain weave fabric is the most common fabric construction found in reusable surgical gowns, and most are produced from cotton or polyester blends or a polyester. Tri-laminate fabric are composed of a microporous membrane between layers of woven polyester and knitted polyester. While in the case of disposable gowns, non-wovens are used which are produced directly from fibers or fiber solutions and the process can be divided into two steps: web formation and bonding. Non-woven fabrics are characterized by fibers more randomly oriented than yarns found in woven fabrics. This successfully increases the potential for the formation of capillaries, thereby reducing liquid transmission. In addition, the random orientation provides filtering media more effective in trapping bacteria and bacteria-carrying particles. The composite no-woven fabrics commonly used in surgical gowns are three-layer structure of no-woven fabrics combined in a sandwich form. They can be produced from a variety of no-woven fabrics, with the most common being a spun-bond med-blown spun-bonded polypropylene composite, and the spun-lace wood pulp or polyester. Then came the final finishes of the fabric applied on the fabrics. Both woven and non-woven products are sometimes reinforced with additional layers to provide increased barrier effectiveness. The finish type most widely used in protective apparel for healthcare workers imparts repellency and antibacterial activity to the fabric. To enhance the repellency of a surface, the surface energy is reduced by treating the fabric with chemicals to alter the surface energy. There are a number of chemical classes of repellent finishes used in the textile industry. Fluorocarbon-based finishes are most commonly used in protective apparel for healthcare workers. This class of repellent finishes is successful in reducing the surface energy of the fabric sufficiently to repel both the water and oil-based liquids. Antibacterial agents are those that kill or inhibit the growth of microorganisms, which includes the alcohol oxidizing agent, heavy metals, acids, aldehydes, and surfactants and antibiotics. Now, the gown design. The gown must allow adequate freedom for the workers to move and design to fit a diversity of the body shapes and sizes, as most healthcare facilities will stock only a limited number of sizes. The gowns are easy to put up and remove without contaminating the worker or the workplace. Although they must prevent the transmission of fluid, they must allow airflow to properly ventilate the worker's body heat. Both woven and non-woven products are sometimes reinforced in those areas that are exposed to the highest level of blood exposure to aid in the prevention of transmission and improve their barrier quality. This is commonly accomplished by adding an additional layer of fabric and microporous membrane in the areas most likely to be exposed to the blood fluids. Some non-wovens are reinforced with a polyethylene film or microporous film to increase barrier effectiveness. The precautionary guidelines for the surgical workers. A number of major organizations have published guidelines for the healthcare workers to minimize risk of exposure, which include recommendations for the personal protective equipment. These organizations include Center for Disease Control and Prevention, which is also called as CDC, Association of Perioperative Registered Nurses, AORN, Occupational Safety and Health Administration, the Operating Room Nurses Association of Canada, Association of for the Advancement of Medical Instrumentation. Now the standards for surgical apparel. Organizations in the US, Europe and Canada are preparing new performance standards for protective apparel, gowns and drapes, which have either recently been published or are entering the final development stages. Both US and European performance standards rely on quantitative test methods that should allow end users to make better decisions, because they will be better able to compare products. The organizations providing performance standards are American National Standards Institute, Association for the Advancement of Medical Instrumentation, European Standards and Test Methods, European Committee for Standardization, Canadian Standards Association. Now the stitching machine used for the surgical gowns, and the stitching machine used for surgical apparel swing is ultrasonic lace swing machine. Its features are with ultrasonic generator, horn vibration energy and pattern sealing wheels enable tight runs of material in the sealing or cutting. Design pattern change of rollers enables sealing, cutting more quality, beautiful and strong. It enables straight or curved sealing cutting to meet application requirements. It provides a benefit over conventional stitch. Needs no needle and thread, cost down and easy operation. No stitch holes prevent penetration of liquids, bloodborne particulates. Provide air watertight or watertight air through effect. Operational jig can control quality and increase production speed. Special arm design enables sealing, cut off or sleeve more steady and faster. Now the specifications of the machines are materials such as nonwovens, fabric, polyester, nylon and thermoplastic films can be processed on this machine. The typical applications of these machines are in field of medical surgery garment, disposable, hospital gowns, surgery caps, shoe covers. Now this is the specification table of this particular machine, in which the model is also of two types: output power, frequency, motor speed, welding bed width, line source, working table, air source, net weight, machine size, thickness of the material which is to be stitched. Now comes to the manufacturers which manufacture the surgical gowns in worldwide. I especially hold in Pakistan and China, which are H.A. Chauhan, Baba Sports, Al Rahim, etc. These are in Pakistan, while operating sector medical in Hyundai Corporation Limited in China, Shanghai, in Drapes Medical Supply Corporation, etc. These are in the China. This is all of my presentation. Thank you for patience. Thank you.